Hey everyone, I'm Alian, and I'm back with my series of taking you through the process of designing my very own experiment. Last time, I learned about the problem I'm trying to solve, fertilizer runoff, and how microalgae can fix it. And today, I'm going to be coming up with what my experiment's gonna look like. So here's the situation. I know generally what my experiment's trying to find. I'm trying to find the rate at which microalgae are able to absorb nitrogen and phosphorus from wastewater. And my plan for doing this was to grow the algae in my basement using a structure called a photobioreactor. Photobioreactor is basically a fancy word for a tank filled with water that is able to let in light. And this is the ideal environment for microalgae because it has everything they need to perform photosynthesis. That is, light, water, and carbon dioxide from the air. So here's what my photobioreactor is going to look like. It's basically a big bottle filled with water with LED lighting and an aquarium bubbler to circulate CO2. I'm planning on building 3 of these so I can test different conditions for the microalgae in each one of them. The other thing microalgae need is a lot of nutrients. And 2 of these nutrients happen to be nitrogen and phosphorus, which is why they're so good for wastewater treatment in the first place. In my experiment, I'm going to be testing 3 different concentrations of nitrogen and phosphorus in the water, in each of those 3 different photobioreactors I just talked about. Photobioreactor, or PBR number 1, is going to be my control group. This one's going to have optimal concentrations of nitrogen and phosphorus that are ideal for the algae to grow. PBR number 2 is going to have nitrogen and phosphorus in wastewater-like concentrations. Wastewater typically has less nitrogen, but more phosphorus than the optimal conditions. But for microalgae wastewater treatment to work, we need to make sure that they're able to withstand these conditions and that they're able to absorb nitrogen and phosphorus quickly enough. PBR number 3 is going to be pretty similar to PBR number 2, but with more nitrogen and more phosphorus than PBR number 2. This is meant to represent fertilizer-heavy wastewater. If you remember from last time, a big problem in the world is fertilizer runoff, where the nutrients we put into plants, nitrogen and phosphorus, end up going into our water supply, contaminating it and making it unsafe to drink. Since microalgae can combat that, I want to test if they're able to withstand the high nitrogen and phosphorus concentrations that are present in fertilizer-heavy wastewater. So with these 2 concepts in place, here's how my experiment's going to work. Step 1 is getting the microalgae, which I'm going to be getting from the Canadian Phycological Culture Centre at the University of Waterloo. Shout out to Heather there for meeting with me and answering all my questions. Then, since the microalgae comes in a small tube, I'm going to have to grow it up so that there's enough to fit into every photobioreactor. Then, I'll be able to split that amount of microalgae into each photobioreactor with the different nutrient concentrations that I just talked about. Every day, I'm going to measure the nitrogen and phosphorus concentration in each photobioreactor, which will give me a curve something like this. The amount of nitrogen and phosphorus will decrease exponentially as the microalgae grow until they've consumed all of it. All of this will answer my question and tell me how fast microalgae are able to absorb nitrogen and phosphorus from wastewater. So there you have it. With my experiment ready to go, I can finally start the building process. The next episode is going to be about constructing the photobioreactors that will be so crucial to the experiment. But until then, feel free to subscribe down below, and I'll see you in the next one.